Alright, the first thing we're going to do is let the angles equal something. So inverse tan 3/4 is an angle, so let theta equal inverse tan 3/4. And this part, inverse tan of a third, is also an angle. So let's let like alpha equal inverse tan of a third. And from that, we have tan alpha is equal to a third. And then what we can do, once we've kind of set that up, is take tan of both those angles, tan of both angles of both sides. So taking tan of both sides, we've got tan of, and there's theta, right? Tan of this angle is tan theta. Excuse me. Sorry. And if I look at the right hand side and take tan of that, I'm taking tan of 2 lots of, and that angle is alpha, so 2 lots of alpha. All right, so we already can tell that tan theta, if I basically rearrange this, we can see tan theta is a quarter, sorry, 3/4, and I could write, I'm taking tan of inverse tan 3/4. There we go, so tan of inverse tan, we'll just get 3/4. So we have to show the right-hand side equals the same thing. Now the right-hand side has a double angle in it. So using the identity here for the double angle, so tan 2 theta is the same as, 2 alpha, 2 tan alpha on 1 minus tan squared alpha. All right, so now we've got it in terms of single angles. And remember, our tan alpha is a third. So we've got 2 lots of a third divided by 1 minus a third squared, which is a ninth. So we can see that's 2/3. This, can you see that? All right, so 9, so this would be 8/9. So I'm timesing by 9 on 8, which gives me 3/4. So now I can say, oh look, left-hand side equals right-hand side. Therefore, this is true. Inverse tan of 3/4 equals 2 inverse tan of a third. All right, and I'll do exactly the same with B. So let's let theta equal, in this case, the angle would be inverse cos x on this side. And then you can see that I'm going to take cos of both sides anyway. And alpha equal, this whole thing is the angle. There we go, that's the angle. Inverse cos of 2x squared minus 1. All right, so, you know, if I did have a look at taking cos of just theta, I would definitely get x. And if I take cos of alpha, I will get 2x squared minus 1. All right, let's take cos of both sides. So if I start at the left-hand side, I've got cos of 2 thetas. Yeah, cos of 2 thetas. And if I start on the right hand side, I've got cos of inverse cos of 2x squared minus 1, which we know is 2x squared minus 1. So that's what I'm looking to get. Again, using double angle formula, this would be, in terms of causes, single angle causes, get 2 cos squared theta minus 1. And if we have a look in terms of causes, cos theta is x, so this is 2x squared minus 1. So you see that the left-hand side does equal the right-hand side, therefore this does equal this. All right.